Hello, this video is going to be on 14.4, which is on the volume of prisms and cylinders. First thing to do is to update our formula chart. So let's begin there. So formulas for chapter 14. So far we have dealt with area. We have talked about lateral area and surface area for prisms, cylinders, pyramids, and cones. So remember that for a prism, lateral area is the perimeter times the height, while the surface area is the lateral area plus the area of the two bases. For a cylinder, the lateral area is the circumference times the height, where the surface area is the lateral area plus the area of the two bases, which would be the area of two circles. In a pyramid, the lateral area is 1/2 PL, where L is the slant height, and this full surface area is the lateral area plus the area of one base. The cone has a lateral area of pi RL because we're taking half of the circumference times the slant height. And the surface area is going to be the lateral area plus the area of the base, which is pi r squared. Okay, so now we're going to turn to volume. Today we'll do volume of prisms and cylinders. The next lesson will be for pyramids and cones. And then the final lesson of this chapter is going to be on spheres. Okay, so the volume of a prism. One of the things that you need to know for this is Cavalier's principle, not Cavaliers. Cavalier's principle says that any two-dimensional figures who have the same cross-sectional area all the way through are also going to have the same volume. So that is, I'm going to show it to you in the book. That is Cavalier's principle. If two three-dimensional figures have the same height and the same cross-sectional area at every level, then they have the same volume. So from that, we can derive a formula for the volume of a prism, which is volume equals the area of the base times the height of that prism. Because if you take that base all the way up, the area of it times the height is going to give you the volume. The volume of a cylinder is similar to that of a prism, only we know the area of the base of a cylinder is a circle. So we have pi r squared h. So let's add that to our formula charts. So the formula for the volume of a prism is the area of the base, shown by capital B, times the height of the prism. For a cylinder, it is pi r squared times the height. Okay, so let's take a look at problem number 1 in your textbook on page 580. Okay, problem 1 wants us to find the volume of a rectangular prism. Okay, and the prism has dimensions of 10 by 20 by 24. So 10 by 20 by 24. Now, I didn't make my figure exactly proportional. All right. And we're dealing with centimeters. Okay, so in this case, we have the volume of prism. So volume is going to be the area of the base times the height. Now, in a rectangular prism, you may have learned that it is length times width times height, which of course is true because the area of the base is length times width. So we can just take our 3 dimensions and plug them in, and that will give us our volume. So we have 10 times 24 times 20, which will be 240 times 20, which is in turn 4,800 centimeters cubed. Okay, pretty straightforward, isn't it? So how about finding the volume of a triangular prism? So a triangular prism, problem 2. So this is an isosceles. Oh, actually, it's an equilateral triangular prism. I am not very happy with the way that I drew that, but we'll make it work. Okay. So each of these sides is 8, and then the height is 10 inches. Okay, so our volume is the area of the base times the height. In this case, our base is a triangle, so it's going to be 1/2 lowercase b, as in the base of the triangle, times the height of the triangle times the height of our prism. Okay, so I'm using a triangle to indicate triangle and P to indicate prism. Now, I could also find this by itself first and then plug it in for B. So how am I going to get the height of this triangle? Well, I've got a right triangle, don't I? And this is an equilateral triangle, so I also know the angles. This is 4, this is 8. That's 60 degrees right there. So I already know, even with that Pythagorean theorem, that this is 4√3. So I plug that in for my height of my triangle, and I have 1/2 times the base of my triangle is 8, the height of my triangle is 4√3, and the height of my prism is 10. So I have 1/2 of 8 is 4, 4 times 4 is 16, 16 times 10 is 160 square root of 3 inches cubed. Or if I put that in the calculator, I would get 277.128 inches cubed. Okay, how about finding the volume of a cylinder? Okay, the volume of a cylinder on page 580. Okay, volume of a cylinder. What's the volume of the cylinder shown in terms of pi? So we have a cylinder with a radius of 3 and a height of 8 centimeters. Okay, so volume of a cylinder is volume equals pi r squared times the height. So this will be equal to pi times 3 squared times 8. So that gives me 9 times 8, which is 72 pi. If you're supposed to leave it in terms of pi, that would be your final answer. And this problem does want us to leave it in terms of pi, so we're done right there. Okay, how about finding the volume of a composite figure? Composite figure means we have more than one three-dimensional figure, or more than one shape that is coming together. So, composite figure. So for composite figure volume, in this example, we have an aquarium. Shaped like so. Okay, so essentially we have a prism plus a half of a cylinder. So this is a rectangular prism. Plus half a cylinder. Now let's see what the dimensions are on here. Our dimensions are, this is 24 by 24, and the entire thing here is 48 inches. Okay, so how can we figure this out? Well, we know that we can assume in this case that this is a half cylinder, and so we know that the diameter of our cylinder is 24. So the diameter equals 24. So that means our radius is equal to 12. So that means that this right here is 12, which means that this is going to be also, this will be 48 minus 12 is 36. So now we have dimensions for our prism, and we have dimensions for our cylinder too, if we remember that this 24 is also going to be the height of our prism. Okay, so let's write this down, or of our cylinder, sorry. Okay, for the prism, volume equals the area of the base times the height. The area of my base is equal to 38 or 36 times 24. And my height is equal to 24. A lot of things that are the same here. Okay, so the volume of my prism is 36 times 24 times 24. That is going to be 20,736. And this is in inches cubed. Now, how about my cylinder? My cylinder volume is going to be volume equals pi r squared times height, but I only want half of that, right? Because it's just half of a cylinder. So I have pi. We said our radius was 12. Our height was 24. And we're going to divide that by 2. So essentially we have 12 cubed because 24 divided by 2 is 12. And so 12 cubed times pi. We're going to put that in the calculator because for this answer, we really do want to have a final answer with decimal approximation instead of our answer in pi. So we have 12 raised to the third power times pi. And that is 5,429 approximately. Okay, finally, we need to add these two together. So we have 20,736 plus 5,429. 26,165 inches cubed for our total volume. Okay, so that covers what you need to know how to do for this lesson. In this lesson, you need to be able to find the volumes of various figures, remembering that we're still interested in the height of our cylinder, even if it's a slanted cylinder for our formula for volume. You have some composite figures. Sometimes we didn't work a problem like this, but I believe in your ability to work a problem backwards and find height from the volume. And then there are some composite figures that you need to be able to look at and figure out as well. All right, good luck with your homework, and I look forward to seeing you next class.